make up some quick questions. Let's see what you remember. I'm just gonna call on people, so be ready to unmute. Let's see. I'm just gonna randomly pick someone. Eyes closed. All your names are just across the screen. All right, this question is going to Kanye. My eyes are closed, Kanye, because I know you're looking like, oh my gosh, I can see you rolling your eyes behind your black screen. All right, Kanye, please tell me the state of matter where the particles slide and glide over the top of one another.
Wait a minute, let me look at my notes.
Say again?
Can I look at my notes?
Yes, you can, but there's 3 states of matter. Think about, listen to what I'm saying. They slide and glide and flow over one another.
Wait a minute, I'm thinking. I sure forgot.
Tell me the 3 states of matter then first. Don't ask Siri, come on. I hear you asking Siri. Listen, tell me the 3 states of matter first.
I honestly didn't forgot, Miss Peyton.
You know the 3 states of matter?
What is that?
I'll do it.
All right, come out with the 3 states of matter.
You talking to me?
Anybody? You can go.
Gas, liquid, and solid.
Okay, thank you. So, with gas. So now tell me the one where the particles slide and glide and
gas.
They do technically, but they're not that spaced apart. So they're a little bit closer together. So which one is that?
Solid.
Closer,
No.
not super.
Liquid.
Yes. Hey, you got it eventually. Yes, liquid. All right. Next question goes to Stephanie. All right, Stephanie, tell me the state of matter where the particles vibrate in place. They are very tightly packed together.
Solid.
Very nice. Next question goes to Nikaya. All right, so I need the phase change where you go from a solid to a liquid. Solid to a liquid.
Melting.
Melting, very nice. All right. Think of another question. Let's see. Okay. Elmer, all right, here's your question. If I say that my cup is silver, is that a physical or chemical property? My cup is silver. Physical or chemical property?
Physical.
It is physical. Thank you. All right. Eris. All right, Eris, your question is, this state of matter, the particles are very spaced apart and I can compress them or they can expand.
Gas.
Gas, very nice, thank you. Let me think, what else? Let's get into these space changes. All right, this question is for Jasmine. All right, Jasmine. Sometimes in the morning, the grass is wet. There's dew on it, okay? There's dew on the grass. Do you remember the name of a phase change that is? That's an example of what? Of which phase change? Are you there, Jasmine?
Is it physical?
Is it, so phase changes are like melting, freezing, condensation, vaporization, sublimation, deposition. So which one is dew on the grass or the water on the side of my cup? Do you remember that one? So water on the side of the cup or the water on the grass in the morning. Let's see. And then I have another, let me see what else question I have. We'll do like one or two more. You got another guess, Jasmine?
Yeah, I'm trying to think.
Okay. Mm,
Is it a condensation point?
condensation, very nice. All right. Okay. I have to think of another question. This goes to Jessica. All right, Jessica, this, if I add heat to a solid and it changes into a gas, so I went from a solid to a gas, I need to know what the name of that phase change is.
Would it be evaporation?
Not quite, you close. That's if you're going from a liquid to a gas, but I want to go from a solid to a gas. So it's one of those weird words, weirder words. Want to take one more guess?
You said from a solid to a gas?
Yes, solid to a gas.
Is it sublim? You know what I'm trying to say, though, right? Okay.
Sublimation.
Yeah.
All right. Last two questions. All right. This is, oops, Michael. All right, Michael. If you drive by and you see an old car outside in someone's yard and it has rusted away, it's rust all over it, is that a physical or chemical property?
It's a chemical property.
It is a chemical property. Very nice. And last one. Ooh. Ooh, this is a good question. Okay. This is I'll save it. All right, whoever gets this, if you get it right, I'll be super impressed. If you get it wrong, that's okay, because I'll tell you why. All right, so this question is for, oh, he already went. Muhammad. All right, Muhammad, here we go.
Choosing.
I didn't, well, at first it landed on Kanye, but Kanye,
Yeah, but I felt it. I knew it was going to be.
I promise you I didn't pick you on purpose. All right,
Yeah.
here's your question. Dissolving, is that a chemical change or a physical change?
Can you repeat the question?
Yes, dissolving. So like if I put sugar and water and I stir it up, or salt and I stir it up and it disappears, is that a physical change or a chemical change?
Physical.
Very good, Muhammad. Kudos to you. Let me give you a clap. Hold on, I know how to do this. There we go. All right. I was like, where is it? That's what I was like. Anyway, so that was probably the most missed question on the quiz across all classes, okay? So dissolving is a physical change, but that leads us into our chemical changes. So get ready to take notes. Here we go. I'm going to pull up my whiteboard here. And we are going to talk about today chemical changes. Let me maximize this. All right, chemical changes. So yesterday we talked about physical changes, specifically phase changes, but a physical change is anything that when you make the change, you still have the same stuff, okay? So if I take a piece of paper and I tear it in half, or I ball it up, or I rip it, or whatever, or I color on top of it, it's still a sheet of paper. So that's a physical change. Okay, in contrast, when we have chemical changes, all right, the way we kind of defined it is a chemical change. So when you have a chemical change, okay, a chemical change involves, it's gonna have to do with, and I'm not gonna write this down yet, but I just want you to listen for a second. It has to do with an atom's electrons. So if you don't know, if we were to just pretend, you don't have to write this, but if we pretended that this was an atom, okay, realistically, there's protons in there in the center, there's protons, okay, and then there's neutrons in the center. So those are kind of in the heart of the atom, okay? But then on the outside, we have electrons. So remember, like back in, we used to draw those rings, and then out here, there was those little dots. When we have a chemical change, that's what's changing, is these guys right here. These are the ones that are changing, okay? So in a chemical change, all right, when you have a chemical change, the substance changes to form new substances, okay? Right? In other words, whatever change you did to it, now you got some new stuff, okay? Like when we were talking about yesterday with my chocolate bar, if I left it in my car, okay? If I leave my chocolate bar in my car, it's gonna melt, but at the end of the day, it's still chocolate. I may have to lick it off the wrapper instead of just picking it up and breaking it into pieces, but it's still chocolate, okay? Now, on the other hand though, for instance, when we're talking about paper, if I pick up a piece of paper, okay, and I set it on fire, I'm gonna get a bunch of new stuff. I'm gonna get ashes. I'm gonna get whatever the dust stuff is left over. The paper is gonna be gone and I can't get it back, okay? So usually chemical changes are not reversible. Let's make a note of that, okay? So usually there's always an exception, okay? Let me find my pen here. Usually, I'm going to shorthand it. Chemical changes are not reversible or irreversible, however you want to say it. All right, so once you made that change, that's it. That's what you got now. You got smoke, you got fire, you got ashes, but you don't have a sheet of paper anymore. Okay. All right. So they have they're not reversible. You're also going to get new properties because you got something new. You got new stuff. So you're going to have new properties. So it's not the same color. Okay. Maybe now it is, it's a different color. It smells different, all that kind of stuff. Okay. So, we're going to do something called a memory sentence. Okay. So a memory sentence, give me 1 second here. A memory sentence is something that kind of helps us, it helps us remember, like, what's the words I'm looking for? You know how I used to write sentences and then each letter represents something? That's basically what it is, okay? So here's the memory sentence, and honestly, I would love if we could come up with a new one, because, I mean, this one's fine, but whatever. All right, so here's the memory sentence for chemical changes, and it kind of just helps us remember. So it is, let's do a different color here. Old, I just forgot to finish, y'all. Old grandmas. Oh yeah, old grandmas, country pies taste lovely. Okay. Old grandma's country pies taste lovely. Old grandma's country pies taste lovely. So you guys write that down. Leave space. So I'm going to write something. In other words, I'm going to write something under the O, under the G, under the C, P, T, L. They're all going to represent something different, okay? And it just kind of helps us keep up with signs of a chemical change, okay? So this is going to help us remember, I'll write it right here. Sign, oh, I do ink. Signs of a chemical change. Okay, signs of a chemical change. All right, so let's see. I am going to give you guys an example, and I want you to tell me what you would possibly notice that represents a chemical change because you get new stuff. All right, so let me see who I haven't called on. All right. All right, Josh, if I were to go camping, okay, and it is late at night, and I need to burn some wood, okay, because I'm camping, right? I'm camping, okay? Tell me something that would be different about the wood, or tell me what you would see if you were out there. Or what would you notice? How would you know I'm camping if you were just out there and you saw me setting a fire? How would that be?
How will I know you can't? I guess the tent. I don't know.
Okay. So let me rephrase that because I'm trying to figure out how to get you to say what I want to say, but I know I'm making it difficult how I'm asking. Okay, tell me this. Tell me one reason why I may want to like do a fire. Why would I want to do a fire if I'm camping?
Maybe so you can like eat or like won't get cold.
So I won't get cold. Very nice. All right. So if I burn wood, one of the things that you guys would see that would be different is a change in temperature. Okay. Temperature. Okay. So if you see a temperature change, if you were doing something and the temperature drastically, doesn't even have to drastically change, but the temperature changes, it heats up or it cools down, you had a chemical change. Okay, so temperature, that is one thing. Somebody else tell me another reason why I would need a campfire in the middle of the woods. What else could it help me? What if it's
it can also help you like see stuff, I guess.
Okay, so anytime light is produced, you also had a chemical change. Okay, very nice. Okay. Let's see. What about if your eyes were closed? If your eyes were closed, how else could you know? This is anybody. If your eyes were closed, how else could you know that there was a fire out there in the woods? Isaac, what do you think? If you were sitting in the woods, if you weren't even near me, how would you know that there was a fire in the woods?
You could smell it.
You could smell it. Very nice. All right. So if you notice a change in odor, okay, if you notice a change in odor, then you also have a chemical change. All right. Somebody tell me how that wood is going to look different later on. What's going to change about it? Anybody? Is it going to look the exact same? If I burn some wood or I burn some paper, is it going to look the exact same? Somebody better tell me no and tell me why.
No, it's gonna burn into something else, ashes or something.
It's going to burn to something else. Okay. How do you know? Okay, let me ask you guys this. Alexa, if I burn a piece of wood, let's just say it's not burning anymore. How do you know that piece of wood is burnt though?
It's in ashes.
In ashes. Definitely gonna be in ashes. What if I set a piece of wood? Like let's say I set the piece of wood on fire and then I blew it out. How does that wood look different?
I don't know.
Anybody know? Anybody know? I'm on the C. Any guesses for what the C stands for? The change in what? Come on, guys. I got a piece of wood. I burned
The color.
the color. Thank you. Very nice. It's going to have a totally different color. Okay. The color is going to be different, right? I can still have the piece of wood, but now it's going to be way darker. I burnt it. Okay. So the other two are kind of tricky. You're not going to guess those. I can't do it with the wood. But if you see some type of gas evolution, okay, gas. They say gas evolution, but we'll just say gas. Usually what you would see, we see gases all the time, we just don't know it. Usually when we see gas, this is what we see. We see bubbles, okay? So like in your drink, right? There's bubbles, those are gases, that's a gas, okay? And then the other one is kind of, I'm gonna see if I can.
Don't get it twisted.
Yeah, Kanye, don't get it twisted. Mute yourself.
Oh,
Yep.
I'm unmuted.
Yes, you are. With your singing voice here. Okay. All right, the other one's called precipitation. Now, precipitation, I'm going to have to show you guys that one, but it's kind of weird. All right, so precipitation, I literally can have two liquids. It's gonna sound weird, and I wish I had, I should have gotten some stuff. Remind me, somebody send me a message right now, say, Miss Payton, do the precipitation demo. Okay, so tell me to do the precipitation demo, okay? But I can have two liquids and I can mix them together and they will make a solid, okay? They will make a solid, okay? All right, so super fast to review. If something changes in smell, or you start to see bubbles, or it changes in color, or it changes in temperature, or it produces light, you probably had a chemical change. So let's think about some things that are chemical changes. For example, let's say you go to the fair, okay, or the carnival, all right? You go to the fair or you go to the carnival. At the end of the night before the fair or carnival closes, what do they usually do? Anybody know? It's like everybody's getting ready to go home and they send this stuff up in the air and it's nice and pretty. What are they called? Oh, y'all are kidding. All right, I'll find someone to call on. Let's see. Who am I calling on? Lamar. All right, Lamar. At the end of the fair, every night, a lot of times they shoot these, or on 4th of July, what are they called? I just need to lay down before. Are you there, Lamar? Zarina, are you there?
Yes, I'm here.
Okay. Well, can you tell me what the things they usually shoot off on 4th of July or at the end of the fair, what they're called?
Fireworks.
Yes, thank you. Fireworks. All right, now, Charles, can you tell me, if we're thinking about fireworks, which one of these, can you tell me one thing that is evidence of a chemical change out of the old grandma's country pies taste lovely? What do you think is one of the evidences of a chemical change with fireworks?
Wait, can you repeat the question?
Yes. So if we were to go shoot fireworks right now, okay, if we were going to shoot fireworks, can you tell me, do we get to see any of these? Can you tell me any of these that we might see that we would notice with fireworks?
Color and light.
Color and light for sure, right? They light up the sky and they're different colors. Anything else that you guys think you would see? Anybody else? Kaya, anything else you think fireworks would also have?
Like a odor, I guess.
It definitely would have an odor, and there's one more in particular I'm thinking about. Anybody know what the other one I'm thinking about?
Gas.
Yeah, they kind of do have a gas, actually. They do kind of let off a gas. What else? I mean, what else? You need to be pretty far away from them. Why? Besides the fact they'll take your eye out. What else could they possibly do to you, though?
Oh, temperature.
Yeah, it's a temperature change, right? Aren't they super hot when they shoot off? Yes, I'll tell you. Yes, they are. Okay. So fireworks, that is evidence of a chemical change. Okay. If you've ever used hand warmers, okay, if you play a sport, or if you just like hand warmers when it starts to get cold, if there's different ones, but some of them are like you open the pack and all of a sudden it gets hot. Okay, that's evidence of a temperature change as well. Let's think of another one. Color change. If you're cooking something, that's a chemical change. Tell me 2 things you may notice when you're cooking something. Who have I called on? Let's see. Danielle, I don't think I've called on you yet. I don't think I have. Danielle, if you're cooking something, tell me how that's a chemical change. Tell me which one of these you may notice as evidence of a chemical change.
Odor.
Definitely an odor. Hopefully it's a good odor. Maybe a bad one though, especially if you burnt something. And if you burnt something, Cam, what else could you notice if you burnt something while you're cooking?
The smell, the taste, and how it looks.
Yes, specifically, when you say how it looks, how might it look different?
It's like black and like,
Very nice. Very nice. A color change, right? Even if I don't burn it, hopefully most of your food, I don't know if I should eat at y'all house, but hopefully if you cook something, it changes color. I don't want any pink chicken if that's what you're cooking at your house, okay? But hopefully if I come and eat chicken at your house, it smells good. It has a nice color to it, not pink. And hopefully the temperature of it has changed from cold to hot, okay? So all of these are evidences of chemical changes, all right? Let's see, is there anything else I want to talk about with chemical changes? So as a quick review, this is what we've covered so far, okay? So far, we have covered, this is what you should know. We've covered physical and chemical properties, all right? Physical and chemical properties. Do Kahoot next class. We've also covered physical and chemical changes. Now, here's the difference between the two. On this one, you had to do something, okay? You did something to it. You ripped it, you tore it, you cooked it, you burnt it, you ripped it, you crushed it, you did something to it. On this one, it's just the property of it. You're just looking at it, okay? Or you just know something about it. It's flammable. It's the color of it, the shape of it, the texture, its ability to rust, okay? So one is just could it do it? What would it do? And the other one is you actually did something, okay? So then we also talked about just making sure one of the phase changes are always physical changes, okay? Are always physical. Physical changes, okay? They are always physical changes, all right? And then we've also covered states of matter. All matter is made up of two things. Somebody tell me one of the things that matter is made up of.
Volume.
Volume, very nice.
Mass.
And mass, very good. That is a rough M. M. Okay, all matter is made up of volume and mass. Okay, so I'm going to just give you a quick heads up on the homework. Okay, so we're going to be doing a matter concept map. Okay, matter concept map. So we're going to start breaking out matter. We're going to start talking about elements and compounds and mixtures. There's two different types of mixtures, homogeneous and heterogeneous mixtures. And that's what your homework's going to be. Okay. Anybody have questions about physical chemical properties, physical chemical changes, or states of matter? Okay. So actually, let's do this. We're gonna do, maybe we'll do the matter concept map. I'm gonna make a quiz for you guys, and it's gonna cover all this stuff. Okay, so we kind of did physical chemical properties already. So I'm gonna focus on, and we kind of did phase change. So I'm gonna kind of focus on right in here. Okay, so I'm gonna do another quiz.